On the first day of math, mess of math were gave to me. One integral involving Feynman technique. We're kicking off 25 days of Mathmas, and today we're gonna go ahead and cover an integral that's gonna involve the Feynman technique. Now at this point, I don't need to tell you that I covered the Feynman technique on Book of Marvelous Integrals, and it's all about knowing something, needing something, and finding something. So we have the integral from 0 to 1 of x to the power of 3 minus 1 all over natural log of x with some disrespect to x. And as I mentioned, we're gonna go ahead and use the Feynman technique. And the very first thing that we have to do is create an equation f of alpha. And the reason we're gonna do this is because it's gonna help us take the partial derivative with respect to alpha and create a nicer looking integral so that we can solve this without using some crazy technique. Now, this f of alpha is gonna look like this, integral from 0 to 1 of x to the alpha minus 1 over natural log of x. This is one of the classic examples of the Feynman technique because you're gonna see when I take the partial derivative of this function right here, you're gonna see that this natural log of x is gonna cancel out. But let's go ahead and talk about what we need, or what we know, what we need, and what we need to find. So we know that if f of 0, meaning alpha is going to equal to 0, we're going to have alpha equal to 0 here. We have x to the power of 0, which is 1, minus this 1 right here. Well, this entire thing is going to be 0, and that's actually really nice. Well, what we need is we need f of 3, because we want alpha to equal to 3. Because when alpha is equal to 3, we have the original integral right here. Well, that means that we're going to need to find the integral from 0 to 3 of f prime of alpha d alpha. Because according to the first fundamental theorem of calculus, this will be f of 3 minus f of 0, which is just going to be 0. So if we do this, we found our solution. Well, let's go ahead and get started. We're going to take the partial derivative of this function with respect to alpha. That's what we got to do first. So we're doing f prime of alpha. So this integral will now become, now remember, natural log of x, that's going to be a constant, or we're going to treat it as a constant because we're differentiating with respect to alpha. So this integral, or this derivative right here, will now become x alpha natural log of x, because that's exactly how we take the derivative of something where you have a constant to the variable, or you have your variable as an exponent. So we have all this over natural log of x, and look what's going to happen here. The natural log of x's are actually going to cancel out, and that's going to give us a really nice integral here. We have f prime of alpha is equal to the integral from 0 to 1 of x to the alpha dx. Now, look at that. That's really nice, much nicer than this one because we got rid of the natural log of x. So now we're going to go ahead and integrate with respect to x. So now the alpha is a constant. Well, this is just a simple power rule. F prime of alpha is now equal to x to the alpha plus 1 over alpha plus 1 from 0 to 1. If we implement the first fundamental theorem of calculus, by plugging in 1 in here, we're going to get f prime of alpha is equal to 1 over alpha plus 1 minus, and then you plug in 0. Well, that's just 0, so I'm just going to go ahead and write that down. Look what we have. We have f prime of alpha is equal to 1 over alpha plus 1. And now we can go ahead and actually implement what we need to find. We're going to go ahead and take the integral of this function from 0 to 3 with respect to alpha. And look at what's going to happen. We already know this side right here, the left-hand side, is going to be f of 3, which is what we're trying to find. This, on the other hand, it just requires some natural log integration here. This will be natural log of absolute value alpha plus 1 from 0 to 3. And now we're going to go ahead and plug in our 3, and we have f prime of 3 is equal to natural log of 3 plus 1, so natural log of 4, minus, and then we're going to go ahead and plug in 0. 0 plus 1 is natural log of 1. But remember, natural log of 1 is 0. So f of 3, which was the integral we were trying to solve from the very beginning, is now just going to equal to the natural log of 4. And that is the classic example of what the Feynman technique looks like.